So your first blank here is a system of equations. A system of equations is two or more equations working together. The answer to a system of equations is where the two lines blank on a graph. So what did I say goes here? Intersect. So for these problems, there's three different possibilities for your answers. There's one solution, so that means the lines are going to intersect one time. So this is where I would use your two different colors. That just means you're going to have two lines and they cross each other in exactly one point. So for example, right here, this ordered pair would be your answer. Yeah. That's fine. So, for example, in this problem, I would say my ordered pair is 3, 2. But that's where it looks like they cross each other. If yours is different, that's fine. Okay, so there's no solution. Anybody have an idea of what it's going to look like if there's no solution? Gabby? So what's it called when two lines don't touch? Parallel. Yeah, they're parallel lines. And the last one, that's the one that's hard to figure out. Infinitely many solutions. So that means they're going to intersect infinite times, a whole lot of times. Yeah? Yes. They're the same exact line. That means they're like laying right on top of each other. So why would I say infinitely many solutions instead of all real numbers? Gabby? You're exactly right. Like, look at my pen. If I picked an ordered pair over here, would that be a solution to this? No, because it's not on the line. So it's saying any ordered pair that's on these lines. Good job. So to solve these, you need to make sure both equations are in slope-intercept form, and then graph them on the same coordinate plane, and then see where they intersect. So just like I told you before, a big problem that I'm seeing, especially on your test, is that people are having trouble getting equations in slope-intercept form. So go slow and make sure you're doing this correctly. Think about when I'm getting an equation in slope-intercept form, I'm really focusing on getting this y isolated. Okay, so do I ever want to move the y? Like, is it going to help me to say plus y? No. Okay, I want to leave the y right there, and I want to get rid of this x and the subtraction sign. So first I'll get rid of the x by subtracting x. Move it to the other side. So I have negative y equals, remember we write our term with the x first, negative x plus 2. And now how do I get rid of that negative sign? I either multiply or divide by negative 1. So y is equal to positive x, and I'll say plus or minus 2. Good. Okay, so I'm going to use one of my colors again. M is going to be equal 1, B is going to equal negative 2. So remember we always said begin with the B. That's the first point you plot. And then I can go up 1, 1 to the right. So the reason you have rulers on your desk is because think about like if you are doing these problems and your line is crooked. Are you going to get the right answer? No, because they're going to intersect in the wrong spot. So really use these rulers. I'll give it to you on your test too, but no, these don't have any inequalities. So what about the next one? Anything I need to do to this equation? It's already in slope-intercept form, so now I can graph it. My slope is negative 2/3. My b is 3. Before you graph any of this, think about what this line should look like. Does it have a positive slope or a negative slope? It's negative. It's negative 2/3. So think about what direction should your line be going. Okay, like downhill. Okay, always think about that before you graph a line. That's the huge problem I'm seeing. Because the y-intercept is positive 3, the slope is negative. Do you see it? Oh, no. Okay, so your graph is not your answer. Your graph is just how you come up with your answer. My answer is the ordered pair that they cross. What ordered pair is the answer? 3, 1. 3, 1. Okay, remember, find it on the x and then go up or down. Okay, so 3, 1 is my answer. Okay, if you've got that one, go ahead and try to start the next one on your own. Make sure they're both in slope-intercept form and then graph. So what do you notice happened on this one? It's the exact same equation. First equation is y equals negative 2x minus 3. The second one, once I got it in slope-intercept form, y equals negative 2x minus 3. So from that, you should already be able to tell you what your answer is going to be. It's negative 6. Well, I subtracted 6x. So it's negative 6x. Yeah, it's positive, so I subtracted it. So, even though you notice that, you still do have to graph it. And then which way is this line going to go? Uphill or downhill? Mm-hmm. So what is my answer here? Infinitely many solutions. You actually do have to write it out. You cannot abbreviate.
Oh.
It's okay. Every time I spell it, I second guess myself. Because I used to let people abbreviate it, and then I would say, okay, what does IMS stand for? And they would have no idea.
Infinitely.
But in a week, would you still know what it stood for?
No. I'm not very smart.
Okay. Once you've got that one, go on the back one and try that one. You can probably guess what the answer is going to be.
The same thing.
No. Do y'all know this is recording you?
Seriously?
Yeah.
So I was recording. Well, you have to do that for college.
Put a 1 in front of it. Mm-hmm.
So we just keep it in one.
Mm-hmm. Wait, hold on. Guys, everybody look at my paper. So, in this part, I have y equals, what goes right here?
1/2 x plus 1. No, 1/2.
Okay, so look, if there's not a number here, it's a 1. Think about it, it's a negative 1 divided by negative 2. Positive 1/2 x plus or minus 2. Okay, this is a big problem we're having. If you think of this like a fraction and just simplify, it's 1/2. 2 negatives, they make it positive. Okay, so the other one is very similar. Okay, so this is y equals what, Jack? Okay. 1 plus 1, yes. Okay, Jack, what were you going to ask? I want you to graph all of these. It's really not that many you're going to graph. But you should be able to tell from these two equations, what the answer is going to be. Because what's the same and what's different?
I think so, they're gonna be parallel.
Well, no, the slope is the same, the y-intercepts are different.
I think the rule of overseeing can do my homework.
No, but I can give you a little paper one. No, you don't. It doesn't. It's not as bad as it looks. Okay, so again, make sure you actually write your answer. I see a lot of people will graph this perfectly, but then not write their answer.
You do the circle with the
Uh-uh.
dash.
The answer's no solution, so you can do the symbol, or you can write out the words. Okay, so that's a big part of it, is graphing it and then knowing, is it going to be infinitely many solutions, or is it going to be no solution? Okay, so the last one, I want you to take a second and go ahead and read this on your own and see if you can write these equations. Okay, just write the equations and then stop. Once you've written your equations, I want you to try to define your variables. Like write what is x means and what is y means. What is the equation for James? Somebody new. Lauren?
Wait for James.
Uh-huh.
Y equals 35x plus 20.
Good. Okay, and then the equation for Diego? Carson?
Y equals 25x.
Okay, so now I want us to stop for a second and think about what does x represent, what does y represent? Jeremiah?
So y equals 20 miles,
Uh-huh.
and x equals 9 days.
Not days. Weeks. Number of weeks. Okay, so what we need to start getting in a better habit of doing is labeling our x and y axis with this information. So x-axis is going to be number of weeks. And then y-axis is total miles. So did I need all 4 quadrants in a problem like this? No. So don't draw all 4. Now, I will tell you, just because I know the answer, for the miles, I would skip like lines and then count by tens. That way your graph will come out nicely. And really, really use that ruler on this one or you're going to get the wrong answer. I did. Does anybody know what answer you should be getting yet? Yeah? 3 weeks. And how many miles? 125. Do y'all see how hard it is to get your answer doing this? It sometimes gets really hard to do this and to be exact when you're starting to deal with really big numbers like this. This is why I'm going to show you 2 different methods to do this week. Because there's 3 ways to solve systems of equations. There's graphing, there's substitution, and then there's elimination. People always like substitution and elimination. It really depends on who you ask. And it also kind of depends on the way the problem is set up in the beginning. You know what I mean? Like sometimes it's set up where it's really easy to do elimination, and sometimes substitution is easiest. But once you have the other ways, you probably won't use graphing as much when it gets to word problems. One thing I do want to warn you about, though, is on your homework tonight, the first problem, the 2 lines don't intersect in an exact point. They intersect like at a fraction. Okay, so if you ever end up with a problem like that, then all you can do is estimate. That's just like with these problems. We'll get to where we have better ways to solve these than graphing, but if you end up where it's not exactly on a point, then just estimate. Okay?
So do we use graph?
Yes, you do need graph paper for your homework.
Do we have to use graph?
Yes.